Hello everyone. Today we'll be learning how to solve for special derivatives. A quick note. In this video we'll be covering the information needed to solve first derivatives. There are also second derivatives, third derivatives, fourth derivatives, and etc. The process to finding these is very similar, but you'll have to check out other videos. On the other hand, if you want to learn the core basics, continue watching this video. We also won't be covering special derivatives, which each require different methods to solve. But before we do that, it is necessary to know what exactly derivatives are. So, what are derivatives? In mathematics, the derivative is a way to represent the rate of change, or the amount by which a function is changing at a given point. In short, it can help us understand the difference of slopes between 2 points on a function, as you can see here. It is also important to know when you're being asked to find the derivative of a certain function, for which there are two main types of notation. The first type is Lagrange's notation, which is to write a function with a prime mark. As you can see here, f of x becomes f prime x, and h of x becomes h prime x. The other type of notation is Leibniz notation, which is to write the derivative of a function f as dy over dx. This represents the difference in y over the difference in x. You can simply think of it as rise over run, a technique used to find the slope of a line. It is, in fact, very easy to solve for derivatives. We will first look at them in single-term sequences. As you can see here, there is a formula for such basic equations. It is n times x to the power of n minus 1. Essentially, you are taking the power of x of a term, multiplying the term by that value, then subtracting 1 from the power of the term. Let's look at a few examples to make this information more clear. Okay, so in this problem, we are being asked to solve for the derivative of 4x to the power of 3. We will first multiply this term by the power of x that is shown. In this case, the term will be multiplied by 3 because the x term has a power of 3, resulting in 3 times 4x to the power of 3. To finish up, all we have to do is subtract 1 from the power, making the final result 3 times 4x to the power of 2, which would be simplified to 12x to the power of 2. And there's our answer. Let's now move on to a different problem. Here we're being asked to solve the derivative of square root of 10x to the power of negative 1. Because the square root is present, it is easier to change the term's form into 10x to the power of negative 1 over 2. After that, all we need to do is multiply the term by the nth power of x and subtract 1 from the nth power. After performing these steps, we are left with negative 1/2 times 10x to the power of negative 3 over 2. This can be simplified to read negative 5x to the power of negative 3 over 2. Now, let's go over how to find the derivatives of polynomials. In fact, we shall start with an example. In this problem, we are being asked to find the derivative of x squared plus 2x plus 1. Firstly, by following exponential rules, we can rewrite the equation as x squared plus 2x to the power of 1 plus 1x to the power of 0. From here, all that is required is to find the derivative of each term separately and combine them into one function. Here, x squared will turn into 2x to the power of 1, or 2x. 2x to the power of 1 will turn into 2x to the power of 0, or simply 2. 1x to the power of 0 will turn into 0. This is due to the term being multiplied by the nth term of x, which was 0. As we all know, any term multiplied by 0 is 0. Now all that is left to do is to combine terms. Since we can only combine like terms, the derivative of x squared plus 2x plus 1 is simply 2x plus 2. But what if the whole polynomial was squared? If it is, there's a different set of procedures to follow, which is called the chain rule method. First, we take the derivative of the polynomial. The method for doing this was shown in the last example, and then we have to multiply it by the whole polynomial. After this, we follow the same steps for a single-term derivative. We multiply the function by the nth value of the polynomial square, and then subtract 1 from the square. Let's go over an example. In this problem, we are being asked to find the derivative of x squared plus 2x to the power of 1 plus 1x to the power of 0 whole to the power of 4. This was the same polynomial from last equation, but it's all being raised to the power of 4. In order to find the derivative of the whole function, it is necessary to find the derivative of the polynomial. After that, you multiply it by the function itself. In this example, we multiply x squared plus 2x plus 1 by its derivative that we found in the last example, which is 2x plus 2. Now we need to follow the steps for finding single-term derivatives. We take the value of the nth power of our polynomial, which is 4, and we multiply it to the function. After that, we subtract 1 from the nth power to finish solving for a derivative. From here, we can simplify the function to read 8x plus 8 times x squared plus 2x plus 1 to the power of 3. Anyways, that is now for this lesson. Thanks for watching.